I'm about to perform a test of the ballasting resistor that I've designed and put in line between the primary power system of my little turbine-powered helicopter and the starter. The problem has been that the inrush current is too rapid and too significant for the primary power system to absorb it for just a few microseconds. And so it's fallen on me to find some way to make it work. And I discovered that by installing a length of number 4 wire with an overall resistance of about 4 milliohms, that is 0.004 ohms, the inrush current was dampened enough that the PPS, the primary power system that is, works just fine. The problem is that smaller gauge wire of such length and that additional resistance causes the voltage to drop considerably at the starter, well below what the starter manufacturers considers to be the minimum. That is to around 4.5 volts versus what they would like to see a minimum of 9 volts right at the starter, which is this connection point right here, which I've got a meter hooked up to now to measure when I do this test. So again, the basic purpose of this test is to determine whether that early prototype resistor that you see there, just made up out of a chunk of 304 stainless, that's 5/16 inch square bar and a couple of regular wiring lugs, will provide sufficient resistance to slow the inrush current and allow the PPS to function. I'll show you first of all where the PPS is. The PPS is up here in the box, and it is this black box here that contains all the primary power connections. Connection from the battery, the starter output, the alternator input, and the main bus output. And this is the wire going to the starter. It actually comes out along the ship now and goes to the prototype resistor, and from there to the starter. So let me show you now what this would look like in the completed design, assuming the resistor works. So this is the PPS box and the starter output, and it comes down here through R1. R1 is the prototype resistor that I have hanging next to the ship right now, and from there the power goes to the starter and the ground to complete the circuit, and the starter works. Yet to be purchased and installed, and that purchase and installation is dependent upon whether or not this test is successful, is a Kilovac brand contactor. And the Kilovac brand contactor will be signaled by the engine control unit, the ECU, as soon as engine rotation has begun. I have determined that even if the engine is rotating ever so slightly, the inrush current is sufficiently lower that the primary power system, this guy, works just fine. The aim of this is to retain all of the really nice functionality of the Astronics vertical power primary power system. And those are things like stuck starter protection, stuck starter warning, the ability to reset a starter in the event of an over current situation with a starter, the ability to monitor starter current and see it on the EFIS, the ability to monitor and reset the alternator if necessary. So all of those functions, if this scheme works, will be preserved. This particular contactor has a set of auxiliary contacts, normally open and normally closed, and I will be able to use that together with the circuit board that I had designed in China that makes use of surplus thermocouple inputs on the remote data acquisition and control box made by MGL Avionics, to take those thermocouple inputs and turn them into useful on-off, yes-no signal sources for the EFIS system. So what this will now do is it will advise me if this contactor has failed. A very important purpose of this test is to determine whether this resistor would be able to handle the current for a full starting sequence in the event that this contactor were to fail in the open position. The purpose behind that is to prevent being marooned at a remote landing zone in the event that this contactor fails. So one of my design requirements is that the resistor be able to withstand the complete starting cycle current without failing or without causing a fire. And I believe it will. And the reason I believe it will is because I've tested it with number 6 wire, number 6 copper wire, and found that it worked just fine. Except that the wire gets kind of hot and the voltage, of course, is too low at the starter. But I'm willing to sacrifice the rare instance in which a low voltage start at the starter has to be accomplished in order to preserve the ability to get the engine going and get the aircraft removed from a remote landing zone after a shutdown. Okay, so how did I decide on this stainless steel bar? Well, the formula for resistivity is, I've got a P here. That's intended to be the Greek letter rho. Rho equals R, the resistance, times the cross-sectional area of the conductor, divided by the length of the conductor. A little algebraic manipulation. You know that if you want, say, 4 milliamps, you can, and you have the cross-sectional area of the conductor, and you have the resistivity of the conductor, and you have the length of the conductor, you can figure out, you can figure out what length of conductor you actually do need. So it does calculate out to be 5 inches of conductor of 3/16 square, stainless 304 stainless bar is required to produce a resistance of 4 milliohms. The rho is more or less a constant for every alloy or metal, and for the 304 stainless, the number is 0.72 times 10 to the minus 6 ohm meters, and an ohm meter is the resistance that a 1 cubic meter of the material would exhibit if tested. The number obviously is very small, so you end up doing most of the calculations in scientific notation. So as I said, my calculation yield a 304 stainless resistor made of 3/16 steel. That's 5 inches long, and that works out to be exactly 4 milliohms. As I have it put together there with the extra resistance associated with the connections and the wires, the complete circuit resistance now is 6 milliohms, which is fine for this test. It'll do a good job determining whether or not it will work. Okay, so with that, now that you have a description of what's going on, I'm going to set the camera back up here, and everything is ready to give it the test. I want it so that you can see both the minimum voltage, we'll record the minimum voltage during the start test, and also allow us to observe the resistor. The first test I'm going to do is going to be just a brief touch, a brief excitation of the starter circuit, just to see whether or not any sparks fly. I put that chunk of plywood down there to prevent the portions of the ship from being exposed to sparks in the event that any fly. I don't think they will. The calculations are pretty good, so I think it'll all work just fine. Okay, so I have already energized. I'll just verify that. I have already energized the start field solenoid, which shuts it off. I'm just going to verify that it's operating by, should hear click. Yes. Okay, that's all working. So and that will prevent the turbine oil that I put in the fuel pump from being sent into the engine. I want that turbine oil to just remain in the engine-driven fuel pump to keep it lubricated. So the next thing is that the battery power's got to come on, and I charged the batteries last night, and they're up to 14.2 volts this morning. So the battery switch is on. Next thing is the pseudo master switch needs to go on. And now I'm ready to touch the positive terminal of the battery with the circuit that would be the start switch in the event of a real wiring setup here. Okay, so here we go in 3, 2, 1. Okay, something's not working. I gotta figure out what. That's on. Oh, I know what's wrong. I had this little circuit breaker pop. So that's on. So here we go again in 3, 2, 1. Okay, so test number 1. Let's see how hot that was getting. Oh, that wire, that's gonna get pretty hot pretty fast. Let's see. Let's see if it was hot enough to boil. Okay, so it didn't get hot enough to boil during that little test, but it got fairly warm. So I'm going to let that cool down now, and then I'm going to try it one more time with what would be more or less a full dry start, and we'll see what it does. And I'll record that on a subsequent video.